we go. All right. We have a bullet train that's going very fast, and we have a freight train that's going less fast.
Meaning slower.
And the thing we need to know here is distance equals rate times time. Okay? And we don't know how long either of the trains is. We do know that freight trains are 3 times as long as bullet trains. Okay, so I'm just going to say that x is a length of a bullet train. Okay, and we are given the speed of the bullet train and the speed of the freight train, and we're given a time. Okay, 24 seconds elapse. Which means we should be able to find a distance. Okay, we have a rate and we have a time, so that should be like enough to get us a distance. Okay, and from the time the front of the bullet train catches up to the back of the freight train, to the time the back of the bullet train pulls even with the front of the freight train. Okay, let's sort out what all that means. So here is the freight train. Let's even zoom out a little bit. We're going to say the freight train is 3x.
Okay.
Okay. And I'm going to measure things according to the front of the bullet train. Okay?
Okay.
And the other trick that I'm going to do is I'm going to pretend that the freight train is standing still. And the bullet train is going to be going, instead of 210 kilometers per hour, we're going to act as if the freight train, which is going 90 kilometers per hour, is totally standing still. Okay, so we're going to cross that out, count it as 0, and then we're going to subtract 90 from 210, and we're going to say, okay, what we have is a 120 kilometer per hour bullet train that is going to pass a freight train that's standing still. There's no difference from the perspective of the people on the 2 trains, right? Because all we need is a distance. We can adjust the rates however we want. And you know what it's like when you're driving on a highway or something, and you know, if you're going 65 and the person next to you is going 60, it's as if you're going 5 miles an hour.
Yeah.
Right? So, okay. How far does the bullet train have to travel? Well, the front of the bullet train has to travel to far enough so that the back of the bullet train is at the front of the freight train. Okay, so the front travels the length of the freight train, which is 3x, right? The front travels from
Just
here
4x.
to here. Right, so the front travels 4x total. Okay, in 24 seconds at a rate at 120 kilometers per hour. Okay, now the other little deal that we're going to do is we're going to convert 120 kilometers per hour to meters per second.
Okay.
Okay, just because it's a more realistic thing. So 120 kilometers per hour is the same as 120,000 meters. You know about kilometers and centimeters and all that stuff, right?
Yeah.
Okay, how many seconds are there in an hour?
3,600.
3,600. Okay, and now we're just going to reduce fractions. What's 120 over 1200 over 36? It's 200 over 6. Is 100 over 3. Okay, on to the official calculation. Distance equals rate times time. The distance we agreed
206.
200 over 6. So I'm just reducing that fraction.
Okay.
Okay? You are furiously taking notes, which is good. Okay. What's the distance?
The distance is 4x.
4x. What's the rate?
120. Or do you
One.
want to go back?
Oh, we're going to meters per second.
Oh, meters per second. 100 then, or 100 over 3.
Right. And for how long?
24 seconds.
Times 24 seconds. Okay. So the 3 and the 24 make 8. Right? And then that becomes 800. 800 meters is 4x, so x is divide both by 4. X is
It's 20.
200 meters. Okay, that's how long a bullet train is.
Okay.
Okay? Now, going back to the actual question, they were asking us how many seconds would it take 2 bullet trains, each traveling at 210 kilometers per hour, to pass by each other completely. Okay? Again, we're going to do the same trick. And what do I mean by the same trick? We're going to pretend that one of them is standing still. Okay, so we've got a bullet train here that is 200 meters long.
Okay.
Right? And we have another one that is going to pass it. Right? And that means that it has to travel how far?
One that's standing still, so it has to travel 400.
Right, exactly. So it goes from here all the way up to here, and that distance is 400. Okay, and how fast is it going effectively? If one bullet train goes 210, and we're pretending that this one right here, this one is still, we're calling this one 0 kilometers per hour. Okay?
0, okay.
And a regular bullet train goes 210. How fast is it, are we imagining that this bullet train goes?
210.
But this one is also going 210. But we're pretending as if it's going 0. Remember, they're going towards each other at 210 miles an hour. So if you are driving down the highway at 60 miles an hour, and somebody else is driving down the highway at 60 miles an hour towards you, when you collide, let's say, God forbid you collide, the effect is the same as if you're going 120.
Okay.
Because you're...
So now you're going 420.
Exactly.
So they pass each other.
So 420 kilometers per hour.
Like to say if it was going on the other side of the road.
Compared to, we're calling this one 0. Okay, so now we have a distance. We have a rate. Of course, we got to convert our
Wait,
rate.
isn't that one moving though?
Well, we're pretending as if it's still.
Okay.
And we're giving all of its speed to the other train. Remember that the problem is never asking us for a rate.
Well, couldn't we just find 210 kilometers and double it? Couldn't we just find the answer then double it? Or divide by 2?
What do you mean? So that is effectively what we're doing. We're essentially saying, how long does it take one train going twice as fast to go twice as far?
Okay.
I mean, but the point is, we're not asked to solve for a rate. We're asked to solve for a time. And before, we had to solve for a distance. So we can use whatever cleverness at our disposal to reformulate the problem. Like someday you'll take physics and this will all make a whole lot more sense. Like when you're solving a physics problem, the best way to solve it is to choose a frame of reference.
Okay.
Okay, so I'll give you an example. Let's think. I'm going to do a totally separate example. Let's say you're driving in a car.
Okay.
Okay, or you're
Yeah.
riding in a car. All right, and you are sitting in the back. Okay,
Okay.
and you throw a ball up in the car.
Mhm.
You just toss it straight up.
Okay.
What does it look like to you in the car?
Like it's moving backwards.
No, in the car it will go straight up and straight back down
Yeah.
into your hand.
Mhm.
You see what I'm saying? It would be just like we're sitting here at the table. The ball's gonna do, here I'll even zoom in and we'll do a whole, the ball is gonna do this.
Yeah.
The same as if the car were standing still, right? Because you're going exactly 60 miles an hour the whole time. Okay, what does it look like to a person who is standing on the side of the road? Okay, to a person standing on the side of the road, the car is doing this, right? Which means that the ball will appear to take this path
Yikes.
as the car moves. Okay, so I don't know how to do this with the. So the ball's going to look like this to the person who is standing on the side of the road. In other words, the easiest frame of reference to understand how the ball is moving is the frame of reference of the person in the car, pretending as if you're going 0 miles an hour,
Okay.
right? Because if you're on the side of the road and you're just standing here and you look at what's happening to the ball, it looks like the ball is being thrown at 60 miles an hour that way. Right? Do you see what I mean? So we are pretending in this situation, our frame of reference is that we are on this train and we are standing still.
Oh, we're standing still.
Right.
Okay.
And we're asking how long does it take this train to pass us at 420 kilometers per hour. Okay. Next thing is convert 420 kilometers per hour to meters per second. Right? Not so bad. Divide both by 6. That's going to be what? 700 over 6? Okay. Okay, and then now it's just algebra. 400 equals 700 over 6 times time. That means that 2400 over 700 is time. That's another way to say 24 over 7. And of course the problem asked for that like in decimal formation.
Yikes. You don't even get a calculator when you do this.
Yeah, but it's not so bad. I'm just doing it here for my own.
Where did you get 400? Shouldn't you have gotten 420?
400. That was the distance.
Oh, okay. Yeah. This equal the speed is 420 times the time is we don't know, right?
Hold on. Let me just. Okay. So one little thing is the problem asked for nearest 100th. So you just got to be careful to go out one more space because the nearest 100th would be 3.43. Okay, so just pay attention to when you're actually doing the math contest what they ask for. Okay, so this problem actually is easy in that like there's actually no cleverness involved. It's just this distance equals rate times time formula.
Okay.
It's not like these geometry problems where you're like, you have to notice this diameter is in a certain position. This one is totally, anytime you see distance and rate and time, you know what to do. Okay?